Okay. Good morning / afternoon again. Welcome to Lab 6. This is the Seesaw Balance Lab. In this lab, we'll be utilizing stuff you learned from Lab 5, the linear actuator control, to balance a seesaw. So here we have our seesaw apparatus. If you notice, I have the X direction going along the beam of the seesaw. You can use X, Y, or Z, whichever one you deem fit. Just keep in mind that if you use X, the angle is going to be positive or negative, the voltage will change, and the acceleration will change. If you use Z, the acceleration at positive 15 will be the same as the acceleration at negative 15 degrees, so just keep that in mind. So I chose to use X for that reason, and here I have all the wiring set up. Again, the circuit diagram will be posted. It'll be a little messier than this. I've cleaned it up a little bit. You don't need the output from the position anymore because we're only comparing it with the acceleration. So I've taken those out. So you have the accelerometer, which gives you a voltage reading into your analog input. You still have the same digital output over here going to the H bridge to control the motor. And I've built, again, a very, very basic control system for the Seesaw. So this thing is really slow, it's very poor, it's not very accurate, but it'll give you a sense of what's going on. So I bring our apparatus over here. You'll see what's going on. Let me make sure this isn't pulling on anything. So here we have our seesaw balance. I have it compared to the 0 G's voltage, which I've approximated as 1.65. So at 1.65, the gravity is 0, so it should remain horizontal. So if I press run, the actuator is going to extend to a position that causes the seesaw to be balanced. And again, this is a very, very basic, very slow control system. You're going to want to optimize it a little bit. You can use a PID, proportional system, whatever you want, but you'll notice that it overshot, so now it's going back, and it's trying to balance it, and then it'll oscillate back and forth until you stop it, because this is a very bad control system. I wouldn't do anything like this in the real world. But I hope this gives you a decent understanding of what you're doing for the lab. Again, this is completely different from the first 4 labs. You're doing only a control system. There's not much data acquisition. You're going to want to get a graph of this to show the response of the system. So a waveform chart over here inside the while loop to show your control system and the response. From that, you can get time constants. You can get percent overshoot. Anything you need for your control system. All of that should be included in your lab report. But this is basically what you'll be doing for the lab in terms of the control system setup. And again, if you have any questions, the TAs or Dr. Gadsden will be willing to help out. So enjoy and have fun. This is a good lab.